donor advised grant winner, outstanding teacher leader recognition at Newburgh Enlarged City School District, where she teaches at Heritage Middle School for 22 years. And she's a master teacher fellow in the Mid-Hudson region. And she is a climate change research initiative educational ambassador with NASA. And her talk is called Bringing NASA into the Classroom. She's also going to be joined by Matthew Pierce, who's the head coordinator for the STEM outreach program for NASA and a past educator. Okay, take it away, Aileen.
Alex, that I'm a little like emotional. Alex was an educator when even I was in school in Newburgh. So and she ran this planetarium that was amazing. It was like the best gift to be able to go and to see.
Oh, thank you.
We haven't gotten that back yet, but we're working on it.
Working on it.
So yes. So I am starting. Can everyone see me?
Yes.
Okay. I am starting my 23rd year in Newburgh. Teaching middle school, 7th grade science. I was hired, it's very funny. My story is very funny. I was hired to teach AP Bio right out of college. I did not want to be a teacher. Wasn't no part of it. I was doing cancer research in Albany, and my father fell ill. So I moved back home from Albany, interviewing in Manhattan, had a position, and the poor man that I was doing research for had a heart attack. And a friend said, not that that's funny, but said, sub, why don't you sub? I ended up subbing for a former teacher of mine in Newburgh. I don't know if any of you guys know him, Bob Ottens. I know Alex does. And I fell in love with teaching. Like, this is my thing. This is my jam. Went back to school very quickly with a biochem degree to get like my certification. And like I said, needless to say, I was hired to teach AP Bio. Then it kept going down. And they're like, you're teaching middle school. I'm like, middle school? 23 years later, I'm still in the same classroom. I love it. These kids get excited. I want to be that hands-on teacher and come in and do science. So starting 23 years later, I don't know if Matt has joined on. If anyone sees Matt join on, please let me know.
Matt Pierce?
Matt
Pierce is there. Yeah.
Has he come on?
Yep, he's in there.
Excellent.
He's muted. He put his hand up though.
So, I've done some stuff through my career. I've always kept with the middle school kids. I kind of feel like, if you're going to inspire thinkers, if you're going to be able to get these kids to understand how to solve problems, let's do it young. And that's what I've done. I think. Fast forward to last year. I was an adjunct professor for many years at Mount St. Mary College. And a colleague of mine forwarded me this NASA opportunity. They're looking for educators, science educators, to be able to do research with NASA scientists and create curriculum, and bring it back to the students. I was all about it. All about it. I applied for one person and that teacher that she had, she's worked with her now, and I think they're in their 3rd year. So it wasn't open. I kind of felt like, like there's so much to do with NASA. There's so many resources. How do we fix this? What do we do? And then I emailed back Matt Pierce. And Matt, are you on?
Yes, I'm online.
Okay.
Hi.
So then another program was created. So I became a climate change research initiative educational ambassador to NASA. Maybe Matt, you can speak to that a little bit.
Sure. I'll try not to go too long. Let's see if I can get my camera on. All right, can you see me now?
You're on.
All right. Hi, everyone. Pleasure to meet you. I wish we were all together sitting in that field that Aileen is in. And hope everyone's doing well as we can during this time. And wanted to just highlight real quickly our office in New York City and talk a little bit about NASA STEM engagement, climate change research initiative, our citizen science efforts, and hopefully gain some new friends tonight. And my hope is if there's any way that I can support your organization in the future, that we can find some unique ways to do that in building programs. But to pick up where Aileen left off, yeah, she applied for a program that I built and run and called the Climate Change Research Initiative. And briefly, I'm just gonna, if it's okay, I'm gonna share my screen to give a sense of what that program looks like. You may have students or other teachers or friends that might be interested in the work we do. From my vantage point, you should be able to see a PowerPoint slide. Is that correct?
Yes.
Yeah, that's good.
Right. All right. So hopefully that works.
No, it's up. It's up, Matt.
Okay. Awesome. I'm just going to jump forward real quick to that slide. So the purpose of the program that Aileen applied for was to provide teachers to have an immersive hands-on research experience while leading research teams of interns that exist in the vertical team model, and have that run over the course of a year. And ultimately doing community STEM engagement events and us sharing our research portfolio with those teachers and having teachers guide and lead teams on research projects related to climate change. And yes, it's true that the mentor, it was a very competitive application process. We only had 4 teams, and Eileen's passion, enthusiasm, resonance, and exceptional teaching talent really spoke to me and the rest of our team, and we decided to form a group called the Climate Change Research Initiative Education Ambassadors. And the idea behind this program was, although we have our core CCRI program, that the work that's done in there could also be very useful to teachers and students and in communities. So we wanted to form a group with the best of the best applicants that we have to really, continue to expand our impacts and to continue to try to support teachers and students to take on STEM careers and so on. And thank you, Aileen, for all that you've already done, even in the first year. Your passion and talent and superior education skill and love of teaching resonate in everything you do. And to give you all just kind of a brief concept of what we do at the NASA Office of STEM Engagement, it's my role to lead the office at the Goddard Institute for Space Studies, which is in New York City. And which means I work both to support the tri-state area, but we also work nationally and in some cases internationally. If you were part of the lunar eclipse viewing blitz that happened a couple of years ago, that was one example of what we do. But we do offer a whole portfolio of internships, fellowships, scholarships, teacher professional development experiences. We work closely with museums and nonprofit organizations to also engage them in STEM. The GIS has a tendency to be focused on climate, but we also have a vast group at GIS and also around the agency that work on exoplanets. And so they're very often pulling Hubble data or any other of our telescope data that you might be interested from Spitzer or a combination of multiple telescopes. And trying to find those next habitable worlds. So there's some really unique work going on there. It's kind of fun for me to think about when our climate scientists do the work to identify, what's happening on the planet. Now that those lessons are actually are translating to our scientists to identify what a potentially Earth-like planet might look like that's 50 million light years away. As I'm sure many of you know, the Earth has changed over time. It used to be much cooler. As the sun expands and heats up, obviously our climate has changed and is continuing to change. Our current climate issues are not necessarily related to the sun heating up, but more because of our activity on the planet. So it's interesting when we look at where we are in the habitable zone relevant to the sun for Earth as we know it, and as we look for life out into the solar system and the universe, taking those lessons from what we know about Earth to try and find what's out there. And I would suspect that many of you probably have heard of places like TRAPPIST-1 that we discovered a few years ago that had an Earth-like solar system around it. So it's very exciting to engage communities and students and teachers and groups like yours, all who have an interest in STEM and astronomy. I do want to show you one more. So I've got a ton of slides here I can show you, but I just want to show you one more quick one that I think you might be interested in. And if you haven't heard of, well, by a show of hands, let me ask you, how many of you have heard?
I did ask you to do this, Matt, because I felt like this group would appreciate it.
Okay.
And as much as I've done with what we've done in the, like, this is amazing. So
okay. Well, maybe I'll show a few more slides, talk about our mission, but cut me off if I'm going too long and you have more things.
I'll cut you off.
All right. So by a show of hands, I guess you can raise your hand here. I did it a little earlier. If you can, raise your hand if you've heard of the James Webb Telescope.
It's pretty amazing.
Steve's heard of it.
I'm just learning.
So this is one of Goddard's missions. We are eager to launch this. We've been building this for over 20 years. And it's really exciting from an astronomical perspective. It's going to be Hubble's successor, and we're going to launch it hopefully this year. It is the size of a tennis court. The reflecting mirror is 6.6 meters high and 6.6 meters wide. It is the sun shield that you see on the bottom here is as big as a tennis court. So it becomes really fun when we think about, geez, how are you going to deploy that? Well, they have to fold this up in a nose cone of a rocket. launch it to Lagrange point 1, I believe, which is a gravity neutral um, spot where it will get deployed. And the engineers I've talked with say it has to go through something like 196 sequential operations without failure to turn on. And if we mess up, we can't service it because it's too far away and we have no way to get there, except through our various radio transmissions. We are, as it's been explained to me, and our scientists at GIS and Goddard can speak much stronger to this, but our understanding is this is going to show us all the infrared energy in the visible universe. And will also give us deep insights into dark matter and dark energy, as and it'll really change our perspective on what the fabric of the universe looks like. So it's pretty exciting. We're looking forward to that. To give you a real quick snapshot of where NASA is. These are all of our various centers around the country. GIS is right here, obviously in New York City, but on a daily basis, we work with all of these centers around the country. And the work that Aileen is doing gets reported out as an exemplar of our education programs to each of these centers. And so it's a real privilege to work with her and her students. Well, a little bit of a perspective on Goddard. We have actually 6 campuses now. The Greenbelt one is our largest. We built Hubble there. We support the space station communications efforts. If you watch the recent SpaceX Demo 2 launch, we manage the communications for that flight. We also have a launch facility, so if you're interested in seeing a sounding rocket take off, you can visit Wallops. We often send students and teachers down there to launch little mini payloads and have star parties. This is the Goddard Institute for Space Studies. If you've been to Manhattan and been in New York City, there's a little diner down here that was featured in Seinfeld, the Tom's Restaurant one. So that's always humorous.
The Goddard Institute is above the Seinfeld
Diner, yeah.
Which is quite funny.
And there's something poetic about that. I haven't quite figured out my punchline to it yet, but
We're gonna have to
with that.
But I'm sorry.
So
Matt.
yeah, a little quick snapshot of what has Goddard done. You may have heard of these things. A lot of folks don't know that Goddard itself has launched over 16,000 orbital missions. Many of those to low Earth orbit to refuel the space station. We have developed over hundreds of new technologies and contributed to W-FIRST. And just about every satellite and telescope that launches pretty much comes through Goddard
Right.
in one fashion or the other. And cut me off if I'm going too long, Aileen.
No. I'm just gonna say I wanted you to offer that because I felt like this is a community of people that wanted to know what's going on.
Awesome.
I could be wrong.
I think so.
We need to understand and my talk was going to be to preface 55% of NASA's workforce is retiring in 5 years.
Yeah, and are eligible now.
So I think maybe I'm going to share my screen a little bit and let them know about what we did through NASA. And I'm sorry if it's dark because I'm still outside. And okay. If everyone will just give me a second. So my students, I am very, very big in terms of teaching of students should actually do science. Do science. Hold on, it's not coming up. I'll get there. And NASA gave us that opportunity. This program. We got introduced. Hold on, it's almost up here. We got introduced to a program about studying snowflakes. Can everyone see me?
You see your
No one
Zoom
can
session.
see.
I don't see you. I see you're sharing on your screen. It says Zoom.
All right. Hold on 1 second. Nope.
There we go.
Oh, it's good.
Nope. It's, hold on. I have it. Oh, here we go. Okay. So when Matt recreated this program and I got to be a part of it, how do you not do that? I honestly feel like I'm getting a PhD through NASA. And you guys are not in my realm of learning, but this is so valid as to what I was able to apply to my students. So these are two scientists. Can everyone see that screen?
Yes.
Kyle Fitch and Dr. Ann Friedland. Yes? Okay. So what they had done was actually amazing. They created a camera. And their camera, hold on, let me just see if I can get over. If I go over this way. They create, here we go. So what's about the shape of a snowflake? I teach classification, right? How do we classify things? And this was something different. How are we going to help them do this? So I don't know if you knew, I did not know. If we look, now we're looking at snowflakes are not like what. Now I'm almost 50. I look at snowflakes as beautiful, decorative. It's so not that way. We're finding snowflakes that are building up bulk. They're coming down as almost like snowballs. And that's so indicative of the environment and the atmosphere that they're coming down from. And it's alarming. It's alarming. So if my students, we got put on, hold on, let me see. All right, so we talked about clouds. Hold on, let me bring it down to you. So we see, like in this screen right here, crystals. That's how we see snowflakes. We had to understand what those structures were. They're 3 dimensions, and NASA was the one to be able to do that. So my students, their role in all of this, this camera took pictures out of Utah, out of Antarctica, and we had to classify them. I did this with 12-year-olds. How do we do this?
Aileen, if you don't mind, if I wanted to jump in and say one thing. So, as some background, I put in the chat box a link to the platform where they did the categorizations.
I'm
And
trying I have the pictures up.
it was quite a unique experience for me as well to learn that NASA was really interested in snowflakes. And what these scientists are doing at the Goddard Institute for Space Studies in the University of Utah was they wanted to create a camera that could photograph thousands and thousands of snowflakes so that they could build a artificial intelligence algorithm
Yes.
that would classify the different types of flakes as they fell. And from that information, that is the rate and depth and time and shape and concentration of the different snowflakes as they fall will tell our climate scientists some lead indicators about what's happening relevant to climate change in terms of how much is the planet warming. So I just wanted to throw that in real quick. Thanks
Thank
for
you.
letting me know.
Sorry, I'm a little nervous. I'm used to middle schoolers. So having an audience of just adults, I apologize.
You're doing great.
Um, if you can kind of see, and this, everyone can see what I'm sharing. I didn't know. I honestly didn't know. Like, are these seventh graders gonna handle this? They did amazing. So Newburgh Middle School kids created the algorithm for these two researchers for the snowflake. I just that's my role. If we could have continued it, had we not had the, obviously the pandemic, we were gonna do more. We were gonna do so much more. They did an amazing job. I don't know how many of you out there are environmentalists or it's not my realm of understanding. So I'm learning as well. I think the great thing, my students took it on, got it done. They would do it at home. Like having this opportunity to work with NASA, that's what we did. That was it. Every day before class started, I don't know how many of you are educators, but you have a due now. That was our due now. 2 snowflakes, get it done. Let's go. And I think Matt can speak to that about how much the Newburgh students, my students, contributed to that process. Like they did a great job. They did a great job.
Yeah, it was really dynamic. It's really one of the things my work is about. One of the many pieces is about creating STEM pipelines and wanting to reach students at the younger ages. And as a central theme and focus of all the work we do is, do we want to get the public to contribute to NASA's work and become part of the research process. So it was really neat that for students, the work they did was really important
Valuable.
because they got to contribute to an actual research project led by NASA research scientists on this
11
focus
and
to
12-year-olds.
develop
11 and 12-year-olds.
technology. So it was the real work. It's the real work, and that work is still underway. And her students are now part of what we refer to as the NASA family.
Right. So we've gotten to this point. There are other programs. Thank God that we're exploring the Globe Project. I had spoken to Alex about this. Everything's just a little bit on hold, if that makes sense. I spoke with Matt Matt today about, there's other programs, things that are coming up that we can do with virtual learning, and how do we get scientists developed? How do we get these kids to love science, to love all of it? That's kind of where I am. I wish we had more. I think, and Matt, you could probably attest to this. It shut down in March. We were still qualifying snowflakes. But my role here right now, I think, is to say we can create science. We can get these kids involved and know that they can be scientists. I don't know if I ever thought that as a kid, but here I am. And yes, granted a science teacher, but still working for NASA. It's kind of funny when I told my children, I'm going to work, mommy's going to work for NASA. And the first thing they said, you're going to space? And I laughed. I said, no, not even close. I'm too old for that. And it's climate change. And they're like, oh, that's not even cool, Mom. Not even cool. Even my students in the classroom. Are you going to the moon? Like, no. But I think certain groups like this that you guys do understand and you investigate and you're attentive to it, we have an opportunity to make some change, which I think, Alex, is why I was so excited to be able to be here for you. And I'm realizing I'm just very in the dark. I'm sorry, guys. I'm outside. The kids can do it. The kids can do it. They did it. 110%. Created this algorithm for these two scientists that work for NASA. What else is, I think it says enough. Says enough. I don't know. Does anyone have questions? I'm sorry. I don't have too much. I'm sorry. We lost power I live in Pine Bush.
No, I think
lost power for about 2.5 weeks. I only got it back 3 days ago.
Oh, my.
But there's so many opportunities, and NASA's reaching out, especially for an association like this. I'm sure there's educators on here to go forward. I don't know.
I have a question.
Yes.
I'm wondering what the other projects that you could choose to do in the future. And I also wondered, do the kids classify the snowflakes from photographs of them?
Oh, I didn't show that, Alex. I'm so sorry. Yes. Well, so my students that did this are middle school kids.
Mm-hmm.
We thought it was best, and through Matt and through the researchers, the NASA scientists, I kind of said, we need like a spreadsheet.
Mm-hmm.
Them something to look at. They did. I thought I brought it up. I'm so sorry because we're so
Okay.
let me see. Matt, do you have it? I don't know if he has it. No, that's not it.
What are you looking for?
We did give them like a spreadsheet and kind of broke it down. And well, here we are. That's it, Alex.
Okay.
So this is what the kids were given and said, okay, here's your picture. What does it look like? And why does it look that way? And how can you make dimensional, they measured, we did all of those things. Where are you going to go with this? And in the beginning, I did reach out to the researchers and said, listen, this is going to be trial and error. I'm doing this with 12-year-olds.
But it sounds like it worked out.
No, it definitely did. It definitely did. Then we went forward and said, okay, well, what is it? Why is it this way? Make measurements, like all those things that they're supposed to learn in science. Like it was great. It was probably one of the best learning opportunities. And I am very, very big on citizen citizen science. Can they participate in something that is valid, that they're going to learn, that they're going to see some feedback? And they did. They did.
Aileen,
Sorry.
there was a question in the group chat from Nicole. It said she's an elementary teacher and she's going to be in kindergarten with 5-year-olds, and wondered if there's any recommendations for making time for science and approaching it with 5-year-olds. I see Matt posted a link for K-4 from NASA. I don't know if you had any particular thoughts on that yourself.
For the younger ages, I don't know that we have anything like that yet.
So I'll talk briefly about what I just put in the chat box. So this is just this is a website we put together in response to COVID and everyone heading home to figure out how to manage that and teach from home and all that stuff. So we tried to put together a conglomeration of different resources. This link in particular is for K-4. And there's some great stuff in here. I encourage you to explore it. One thing that's really fun is the Mars activities for kids. You may know that we just launched Perseverance, which will be landing on Mars on February 22nd, and it has a helicopter on it that will, travel around the planet and give us a better perspective. But I would start with exploring that portfolio a bit, and you can always reach out to myself or Aileen if you have any direct or specific requests or follow-up questions.
Oh no, absolutely. So part of what I was going to say after the snowflake is that we are looking to develop a group of teachers starting in Newburgh, because that's obviously where I am, to be able to utilize these resources. There's so many. And we just have to break it down. I think even more so now than ever. And do that. Just kind of go, okay, this is what it is. This is how you use it in the classroom. The kids can do it. If my 7th grade classroom can create an algorithm for NASA,
Can't see.
everyone, we have to give them this opportunity. If that makes sense. I don't know if anyone can hear me.
Oh, yeah.
Yes.
Yeah, you're good.
Yeah.
Oh, okay. I'm sorry. I'm still out in the woods.
Huh.
But
So,
oh, here we go. Now I see everyone. All right. So I don't know if anyone has questions for me.
I have a few. Can you hear me?
Yes, I can hear
Much
you.
better now, Tim. Yeah.
Okay. I don't know what happened, but let's see. Relating to your snowflake study, what do the scientists from NASA uh, expect to find that would indicate proof of global warming?
Okay. So we were looking at the size of not just size, but the density of the snowflake. Snowflakes fall now
Okay.
that look like snowballs. Who knew? I didn't know. We found out. So the higher the density of the ice impact is going to directly relate to the amount of CO2 in the atmosphere, which I mean obviously makes sense. So those snowflakes coming down, we're not seeing the same like pretty flaky fancy snowflakes. So that's what the kids were doing. I don't know if I can share it here, but we are seeing like so snowflakes are falling, and in this area as well in the Hudson Valley, that are very dense and looking almost like a snowball, tiny but dense, and a snowball, and you know obviously we're dealing with certain chemical. Why would these water molecules hold so much together at certain temperature? And there's they're not studying it here, but it's coming.
Okay. This is
Does
yeah.
that make
This is
sense? I'm sorry.
how long has this study been going on?
I want to say Matt, it was just brought to me last year.
Yeah, good question. It's so in the beginning of the presentation, Eileen showed a few scientists that were collaborating. You saw Anne Fridland, who's been at GIS for many years. Her postdoc is Kyle, and this is part of Kyle's doctoral research. So the premise of the work has been going on for some time. The creating the mask snowflake ID camera.
At least 4 or 5 years, Matt.
Yeah,
I remember. Yeah.
this part of the activity kicked off last winter, and we started talking about it in late fall. And the hope was that we could get some teachers and students and citizen scientists all over to help contribute to that classification. It is if it's of interest to you, it is my intention to circle back with that team to look for next steps. We've rolled it out through quite a few schools and in
Well, I
different
can do
groups.
that as well.
Yeah,
I have all the information. I can do that as well.
yeah, and it may be ongoing. I haven't got a status update recently on where they are with the transition to the development of the algorithm. My understanding is they need more data and more classifications. We needed to get to about 10,000 observational sets to give them the start for the data they needed to create that algorithm. So I suspect it'll be ongoing for some time.
But
Okay.
we gave quite a huge contribution.
Absolutely. You
Yeah,
created the initial data set that built the framework that
right.
they're now building their foundations on. And I'm not a programmer. I appreciate programming just from a complexity issue, but I know it's a substantial undertaking. And the work your students did really did contribute to that initial foundation.
That's cool.
And there's so many opportunities. So I mean, I feel like you guys have an outreach farther than mine, beyond education, maybe in secondary education, college level, like to bring these kids in. It's so important. It's so important. And that was my role today. Honestly, was honestly to say, let's get these kids involved back in science. So
Are
if
you
you have,
planning to do the snowflake research continued this year?
it's going to depend on what the researchers have found
Okay.
when we go back.
Are do you know what's happening with the school year? Are kids going to be in person? Will it be
In
hybrid?
we don't know yet.
Wow. Okay.
I don't think any of us know. It's gonna be I think teachers will be in school, kids will be home.
Mm,
Um, what that means, and I don't know. I don't know.
right.
You know, so much is unknown. I wish we had more information because this program has been so phenomenal. Um,
Yeah, I think every
when
district is
life
choosing
shuts
what to
down,
do.
life shuts down. Yeah.
Yeah. Well, I wish you luck.
Oh, listen, we're all gonna be good. We're gonna be. But I
So,
would I continue the snowflake? Of course I would. Of course I would. There's a few other projects that if you guys want to invite me back in a few months, Matt can speak to that as well. Like we have the Globe project. We're looking to develop teachers. I'm looking to develop teachers in Newburgh just to be aware of all these resources. And if we go to virtual, it's so important that we have really, sound science spaces.
Absolutely.
um I found a lot that were not great, some were great, some not great. um
Is Matt involved in all of the Zoo Universe NASA projects that are out there, or just the Snowflake one?
Say that again.
Is Matt involved in more than just the Snowflake project that's on Zoo Universe and related to NASA, or is
Yeah,
he
well,
involved with
so my role right now with NASA, I'm hoping to expand that, Matt.
Yeah, I'm involved
He's
in
involved
multiple
in all of it.
projects. Like I wouldn't say I'm involved in all, but we have more initiatives than I can count, and more programs and projects that we engage with. Um, so yes, if you have a particular interest about learning about more than that, certainly feel free to contact myself. I did put a link in the chat window up towards the top called at the end of the hyperlink it says Express. And if you sign up for that listserv, you'll get a weekly brief of a whole lot of what's happening in NASA education projects and platforms and opportunities. Often those are targeted at different groups. Like tonight, we had a request for 5-year-olds, and we do work in those domains. We also work across all grade levels, university levels. We have a lot of neat citizen science initiatives. So yes, I lead the efforts at GIS, but I'm also part of the agency-wide program. And
I just think it's so important that we make sure that we understand like the effort is there by certain agencies. Let's get it out there. Let's get these kids learning science again. Obviously, this is a group of individuals that just love science. That was my goal today. That came across. I don't know if it did.
It did.
Yes, it did.
Yeah.
Yeah.
But
that's
I
very
have some. Am I on?
Yes.
So far.
Okay. Just two things I wanted to say. One is for Aileen and one is for Matt. Aileen, we do outreach through our Mid-Hudson Astronomical Association. And we go to libraries and schools, and if you have teachers there at Horizons that might want an astronomy telescope night,
I would like an
really-
astronomy telescope night.
well, you're invited.
Well, I hope so.
So yes, you get in touch with us, and we really enjoy doing those kind of things. And just one quick question for Matt, and then I'll get off here. One area that I'm interested in, that I think our club would be interested in, as far as getting a speaker, is about sunspot numbers and climate change. And as a corollary to that, how do the alignments of planets relate to all of this? Do planetary general alignments have an effect on a number of sunspots, which could then have an effect on climate? Do you know of a person, or could you let us know maybe someone in NASA that might want to speak to that
sure.
for our club?
Yeah, one of the things I put in the chat window. I mean, I could give you my opinion on that, but NASA wouldn't consider me a subject matter expert in that area. They'd probably want you talking to a astrophysicist and maybe a solar wind expert. They would consider me an education expert. In the chat window, I put a link on how to request speakers, and this is an active group. And depending, everybody asks for an astronaut all the time, and sometimes that works, sometimes that doesn't. I find that our community tries to respond as much as they can where
So not cool. I'm not an astronaut.
where it makes sense.
We had one here a few years ago on the walkway over the Hudson.
Oh, awesome! Do you remember who it was?
Kimbrough.
Awesome. Yeah.
Not me.
You might
I'm
be
not
able to
an
get some
astronaut.
Kellys.
I'm not cool.
The Kelly, Mark and Scott Kelly are from New Jersey, and we've got Mike Massimino, who worked on the Hubble. He's in New York. So they're around. It's possible. And right now, obviously, everybody's working in a virtual environment. I anticipate NASA's going to be virtual, but if we want to construct an educational webinar and try to get some subject matter experts to answer those questions, we can certainly go on the hunt to find them. I can always ask my local group of scientists, if you have a specific topic or targeted in mind. Typically, when I do those things, my particular office wants me focused on systemic education program and planning. But we'll try to connect people any way we can. So if you have an idea, certainly
Right.
fill out the speakers bureau, but feel free to reach out to me. I'll put my email in the chat window as well.
Okay, beautiful.
Well, and again, they can reach out to me.
Yes.
As the local person. Sorry, I'm going inside, outside. Whoever has, these connections, whoever can say, like, okay, let's bring NASA to where we can. In terms of research, oh God, I don't have a light on. I'm so sorry. Here I am. I think we should do that.
What do you want? Oh.
Sorry, children. My email, anyone can get it from Alex. Sorry, children. It's great.
Okay. I'm wondering if anybody else has any questions.
All right.
I see Jack's hand up.
What's that?
Yeah,
Oh, that's my mute button I keep hitting.
Oh, is that it? I think Eric has his hand up. Yes.
There we go.
Yeah, Eric has a question.
So it's more of a request because Matt's been providing so many great links for resources. So maybe he's got something for this. I manage the labs at SUNY New Paltz. We're getting ready to start classes next week, mostly remote, but we're going to have people in labs. We can't have as many students in the labs because of social distancing. We're going to have about half as many people in labs. But we have laptops that with cameras. And so we're going to have half the students in the lab doing the work, and half of them are going to join remotely, and we'll pair them up as lab partners in the breakout rooms. Now, I've been working on this all summer. It's a little more technical. We're going to go live and see if it really works. But I realized just this weekend that this model of two people working together like this kind of fits how they do experiments on the ISS.
Yeah.
Where the astronaut is there with the eyes and the hands and the doing stuff, and they usually connect with an expert or a team down on the ground. And I'm thinking I'm going to sell it to my students. Today you're going to be the astronaut. Next week you're going to be the expert. And in fact, I mentioned that we had, Shane Kimbrough from astronaut out a few years ago. I got one of his signed pictures. I put it in a drawer. I never thought about it until today. I hung it up on my lab wall because, hey, look, there's an astronaut. This is how the astronauts do it.
Right.
And you guys are going to be that. My students are engineers, physics majors, some biochemistry, and I'm going to sell them on they're doing things the same way the astronauts are. So do you have any resources that I can back that up with? Maybe an explanation of how experiments are done on the ISS or.
So many.
Yeah, I can look. What's coming to mind is a bit overwhelming.
Matt, I have a lot of those.
Yeah.
Okay.
That's exactly if I can be a resource.
Eric, by all means, contact me.
Okay.
You're at SUNY New Paltz?
I am.
All right. I co-authored a book with Dr. Glenn Gare.
Oh, I know Glenn. I used to play racquetball with him before. Now we play pickleball because it's outdoors. So I know Glenn.
All right. So Glenn knows me very well. He contact me.
I'll get your contact through him.
Of course you can.
He'll
And
love,
then
he'll love that we made the connection. So, okay. No, that,
Eric, one thing I'd like to add to that, one, I commend your idea. One thing I didn't mention is I was in the classroom for almost 20 years and built one of the first online high schools back in the 90s.
cool.
And gained a lot of unique insights about distance learning of what worked and didn't. And I'm happy to, in another conversation, share with you those lessons learned. But what you just described was the type of model that took a what I would call an asynchronous, not very deep level learning experience to a very rewarding experience for students, and turning them into a research team and a research model paradigm.
That's what I'm hoping to do this time around. When we had to go remote very quickly, we switched to asynchronous, where I recorded my taking the data and my students processed it and wrote the lab reports. I got some really good lab reports from it, but they were not as directly involved in it, and they each worked individually. They didn't get that collaboration that we get with lab partners, and I want to try to preserve that. And the other thing about physics labs is you touch the physics, and you make mistakes, and then you correct them, and you get your hands on it, and you see the thing, and so we're trying to preserve that if we can. There are people taking bets on how long we last. Heard what happened to UNC, I think. So they're all supposed to be quarantining now, and classes start on Monday, but I'm doing the first class full remote, and I'm doing the second class, I think, will be remote as well, using an online tool that is our fallback, so that if we have to transition, it's a nice clean. We got a plan. I got 4 plans for what's going to happen, but.
Right.
I just realized this weekend, hey, this is what the astronauts do. And I think that's going to help. And I'm glad to hear you've got some experience that may back that up.
And I'm happy to help with that if I can in any way where it makes sense.
I'll get your email and
yeah.
Sorry, Matt and I discussed that today. Yeah. How do we make this better? How do we develop program with science? How is science going to exist virtually?
Well, when you're thinking about education, you have to, going from a classroom to an online space, you're taking a 4-dimensional universe and putting it into a 2-dimensional universe. Yeah. And you have to reframe your expectations of engagement. It doesn't mean that meaningful work can't happen. And I think it can. I think it can be really successful and dynamic. And the reality is the online workspace is going to be a necessary job skill in the future. So
that's also just remote engineering calls where your customer has a problem and you're not going to send the person until you know that you really have to. And in fact, I'm once we get them launched, I'm going across the hall to my office and I'll be online and I can answer questions. I can take my mask off then. And if I have to go into the room to fix some equipment, I'll mask up and do that. But it's gonna make it possible for me to actually, I think, communicate with them this way too. So it's going to be interesting and different, but I think we can make some good things come out of it too.
Well,
I think you need to get your students to create demos.
I think the conversation was just kind of like, we got held up. We got shut down. I had these students doing amazing things. Amazing things. We were starting another project and we have a pandemic. I'm very lucky that we have this. And like I said, that's why I invited Matt into the conversation. I thought so many of you could find that so resourceful. And I hope that's okay. But he's amazing, and we just keep going from there, right? I mean,
Oh, and we have different instructors doing different formats of their courses. Same sections of the same course, but some of them are doing simulations. Some of them are doing totally online with something called Pivot Interactives, which is not simulations. They're videos of real data.
You're
And
getting
we're
choice.
doing this local remote combination with a fallback to the Pivot Interactive. So, and I manage the labs. I support them all. They're all doing the best that they know how to do in their own way. So I think that's the best we can do.
We support it. Science has to be, and I think like I was gonna wrap it up and kind of say, for me, middle school teacher, my kids still, they're babies. They're doing it. They're doing real science. They're doing citizen science. They're contributing to NASA. I'm thankful I have that. Have we done other projects like that? Of course we have. This for me, and Matt is here to contest to that, I will continue with this. I'm very excited. I get to learn so much. I mean, I don't know how many science geeks are on here, but
We're all,
I'm a
Every one of
science
us.
yeah, this group, pretty high ratio.
right. For me, it's pretty much, what do I get to learn? So
Drop
I
a couple
hope this
of
was
links.
great for you guys. I apologize if it isn't with the power for about 2 weeks. No power, no internet. Just got it back on Thursday. But listen, you know what? These kids are doing amazing, amazing things. If we give them the opportunity, and it's time. It's time. Bring science back. I'm sorry. Bring science back. It's on the back and it drives me nuts. Regardless of what it is. So this is not my realm of comfortable. Again, I was a biochemist. I did cancer research for the beginning of my career. This is just great. Great.
All right.
But anyone, Alex has my email. Reach out. Matt's here. We're trying to expand this program and get so many people involved in what the resources are there. And it's not just earth science. It's not planetary science. It's so much. So much. And if I can be a part of that for everyone, I would love to be able to do that.
All right.
Okay.
That's great. Marvelous. Well, thank you very much.
Yeah.
Any
I'm,
any last questions? Yeah. Right. Clapping. Virtual claps. Thank you.
my 12-year-olds, 12.
Would you like me to put your email up on the chat?
Please do. Please do.
Okay.
And then I can, we're trying to build this program with NASA. I'm not so cool with my kids. I told you that. Because I'm not going to space.
Never say never.
I'm not going to space.
I did add some additional links in the chat box. I'm kind of link spamming you all as I think of things that might be fun. There are 2 sites where you can actually go to and download NASA data from current satellites that are free and public and open source.
No,
I also put one of my favorites. I also put in one of my favorites. It's our scientific visualization studio. It's the last one. And this is, I wouldn't say it's the most intuitive and used, but this is basically a contractor that works for us that takes all of our scientists' data and creates very powerful visualizations based on whatever their research and study are.
Nice, Matt. Nice.
And sometimes when I want to space out or forget about the world, I go cruising around this scientific visualization studio, and there's awesome stuff there, from current missions to orbits of satellites to black hole animations, but it's all focused on real data, which is kind of exciting.
Right. And I think if that, you know, I was kind of concerned, like I'm a climate change girl. I'm not space. I've never been space. But I'm learning. For you guys, if there's other stuff you want, space-wise, like please reach out. I was so excited when Alex reached out because I just respected her so much as an educator. So much that I'm just beyond. And I hope I did okay.
Did great.
The kid, listen, like it's about raising these scientists, isn't it? I mean that's my role today. That's my goal.
Sounds like you're getting there.
You're
running a great program.
Come on. I'm trying, girl. I'm trying. They're trying to make me take it over. Al's on me every day.
Mm-hmm.
But
how about if there's no more questions, that we go ahead and drop off the Facebook line, and then we move this to our social session, and we can continue to chat about that as long as anybody wants to stick around.